Hello, this is our video solution for Lab 8. I'm going to go through each of the diagrams for our individual parts, our level 1 diagram for the entire data path, and then I'm going to show the test bench results for the data path. So starting out, we have the address offset adder block diagram. So we got two inputs and one output. The two inputs of the address offset adder are the 32-bit long PC out input and the 32-bit long IMM_out input. The one output of the address offset adder is the 32-bit long AO_adder_out. Next, we have the IMM generator block diagram. As you can see, you got the select input and the in input. You got 12 bits, you got 2 bits, and then you got the out. So you got two inputs, one output. The two inputs of the IMM generator are the 12-bit long in input and the 2-bit long select input. The one output of the IMM generator is the 32-bit long IG_out output. Next, we got the 2x1 multiplexer block diagrams. So you got all of them right here. They all look pretty similar. I guess the one thing you can show that's different is the PC source versus the ALU source versus the WB. They all have the same inputs, which is input 1, input 2, both 32 bits, and the same output, which is a 32-bit output. Like I said, these are the only differences. Next thing, you got the level 0 block diagram of the data path. This shows that it has 7 inputs and 3 outputs. As you can see, 1, 2, 3, 4, 5, 6, 7. What I want to talk about for this, the inputs of the data path, actually that's fine. I think it'll be easier to explain when we get to the actual level 1 block diagram. So this shows that the inputs and the outputs on the data path talked about in the level 0 block diagram, as above. It shows the components in the data path and how they're connected to each other. As you can see, the PC source going to the ROM. You got the adder situation and the offset adder up here, and this is just the typical data path we talk about in the class daily. We have all of our control unit type instructions down here that we aren't using a control unit yet for. And yeah, this is our block diagram. I don't want to waste too much time. I want to keep this video short. Next thing, we got our test benches for the address offset adder. I'm not going to waste too much time. You can just see that it works exactly as we'd expect. Same thing for the IMM generator. I guess it's this one right here. The IMM generator works like how we'd expect. They correctly correspond to each instruction type format, which is important. The sign bit can be different for each instruction type. So for instance, for B type, the sign bit is instruction 7. In our test, instruction 7 was 1, so that was replicated 20 times in the IMM out results. So this essentially shows that this is what we are expecting. And then we got our top level design analysis. I think this one's the most clear. I believe you can see everything like that. So I'm just going to give a little bit of an overview of how this works really quick. So we wanted to make sure that you could see that all the instructions work. So we have an add operation to show the R type working. We have an add I operations to show that the I type instructions work. We have a load operation to show that the load operations work. We have a store operation to show that the store operations work and S type instructions work. We also showed BLTU and BGE operations to show that B type instructions work in our data path. So for instance, the operation in the test bench from left to right in the photo below are add I A3 A04, add I A4 X01, LW A6 0 A3, and BGE A6 A7 34. So this shows that add I, BGE, BLTU, load, and store operations work correctly in our data path. The load operations work because that is when A7 gets a value of 1. As you can see, A7 does get the value of 1. And the next operation, the BGE operation, A6 is compared to A7 by subtracting A6 by A7, which is 4 minus 1, resulting in the 3. The 3 is right here. That's hard for you to see, but as you can see, 3, so you got 4, 1, 3. So that shows that that works. The final underscore out, which is the bottom one right down there, for the instructions BLT UA4A110, they should probably be X's because the value for WB for the WB mux should be X. We set it to the output. We set it to output the results of the ALU to make sure everything's running correctly. But yeah, this is our test bench and it works exactly as we'd expect. I know it's hard to see on the phone. It doesn't look any better on the Model Sim actual version as far as the computer goes, but you have the picture in our document so you can see and check for yourself that all the values set up. But yeah, this works exactly as we'd expect, and thank you.